Welcome to our 10th video on differentiation. Today we're going to be applying the strategies that we covered in the last video on multiple choice slope field problems. So let's get right into this one. So this one, I see that there are some equations with x and y, and I see others that have only a y or only an x. So what I'm going to do is check the variable dependency first, just before I do anything. So here I notice that yes, this will depend on x, right? Because on this row, dy dx is changing. And then it'll also be dependent on y, because see, on this column it's also changing. And now this is where I want to highlight that you have to check multiple columns, right? Because if you just check this one, you can't conclude that, oh, it's not dependent on x. You should check multiple to make sure that you're not just checking an anomaly row or column. So here we know that it's dependent on both x and y, so that means both x and y should show up in our equations for dy dx, which just flat out eliminates c and d because either a y or an x shows up there. Okay, now let's factor the remaining answer choices that we've got over here. And now we're going to do the zeros check. So we've got a 0, dy dx is always 0 when x is 0, right? Just a reminder, when dy dx is 0, you'll see a horizontal line. And then over here, this line, you have to be careful with the labeling here, because this is not y equals minus 2, because that y value right there is a minus 3. So this is a typical pattern from College Board, is to just label only four times on the coordinate axes, and then just let you figure out what the rest of it is. And so there's 1, 2, 3, 4, 5, 6 tick marks between minus 3 here and 0. So that means each tick mark is 1/2, right? So this is minus 1/2, which means that is going to be a minus 1. And we can label this as minus 2, and so on. So the equation for that line is not y equals minus 2, but y equals minus 1. Okay, so now we've got x is 0 and y is minus 1. And when either of these things are true, dy dx must be 0 for all values of x or y. So here, when x is 0, if you plug x is 0 in here, you'll get a 0 times y plus 1. And that is just going to be 0, regardless of what y plus 1 is. Okay? Over here, part B, though, answer choice B, you've got some different story, right? So this is going to be y, and then 0 plus 1, and you just get y, which is certainly not 0 for all values of y. It's only 0 when y equals 0. So that leaves us with one answer choice, which is choice A. And yeah, let's move on to the next one. Okay, this slope field looks a little scarier, but we can manage. So again, I see some varied variable dependencies here. Some of these equations have only x's, only y's, or both. So let's check the variable dependency again and see. So, right, I see this row, as x is changing, dy dx is changing. So dy dx should have an x in it. And it should also have y in it, right? Because if you look at this column right here, it will also have, the slope is also changing there. So now dy dx should have both x and y in it. So eliminate anything that doesn't. So bang, bang, and bang. Wow, we've got 3 answer choices gone just from this one check, right? So all 3 of these choices, these two, it was only x, this one was only y, right? So now we're left with either C or D. So now what we're going to do is let's try quadrant check. So first let's see if we can do quadrant 2. Remember, it's got to be consistent in quadrant 2, and clearly it's not. This slope right there is negative, and that one is positive. So let's stay away from quadrant 2. Maybe we can try quadrant 4, maybe. Unfortunately not, right? It's also not consistent. That slope is negative and that one is positive. So we can't try quadrant 4. So okay, let's just try quadrant 3. This one's consistent, right? All of these slopes in quadrant 3 are negative. So dy dx is less than 0 when, okay, what are characteristics of points that are in quadrant 3? Well, x is less than 0 and y is also less than 0. Right? Graphically, you can see this. So now, let's try a point. Let's say -1, -1. That point is in quadrant 3. And we're going to plug that point in for C and D. And then we're going to see which one will actually uphold the fact that dy dx must be less than 0. So, dy dx for this one, let's just use x plus y. Right, so at -1, -1. If you're not familiar with this notation, it just means evaluate this expression at this value, or in this case, this coordinate. So x is going to be -1, and then y is also going to be -1. You get a -2 here. Okay, great, right? These slopes are negative, and right. So this one works and is not wrong. So now let's try what happens when dy dx equals x over y, right? What happens in that case? Well, if you plug in -1, -1, -1, right? You're going to get a -1 over -1, which will be a positive one, which is bigger than 0. That's not what we want, right? dy dx should be less than 0. So we can safely eliminate choice D, and we're left with choice C. An interesting observation here is that we've also got zeros along the line y equals -x. And this is consistent with this equation, right? If you plug in y equals -x, this will become x plus a -x, which will be 0, assuming that you're on this line. So that's a double reassurance that yes, indeed, answer choice C is the correct answer. Alright, now our final one looks scary, and it is also a little bit scarier than the one we've done so far. So we've got a 0 at y equals 4. That's the only one that I can see here that's clearly indicated to us. So now let's figure out which ones are going to be 0 when y equals 4. And right away we run to a problem. All of these have a factor of 4 minus y in them, right? So if you've got some expression multiplied by 4 minus y, right, when you plug in a y equals 4 there, that is going to be 0, regardless of whatever that expression was. Right, I'm just using this scribble to represent any expression, right? So that is just going to be 0. So what that means is that all of these will be consistent with the fact that dy dx should be 0 when y equals 4. So that was no help at all, okay. I noticed that some of these have only x's and only y's in different combinations of variable dependencies, so I'm going to check the variable dependency. Now the interesting thing is, right, this is not a typical one because for any row, the slope is always the same. So dy dx is not dependent on x, but it is dependent on y. As we can see here, right, for this row right here, dy dx is changing as y is changing. So now we know that dy dx should only have a y in it, not an x, right? Because dy dx is not dependent on the variable x. So we just eliminate the answer choices that violate this rule. So A is out, it has an x and a y. B can stay. C is out because it also has an x and a y. Now we're left with either B or D as our candidates. And the only difference between choices B and D are a y and a y squared. And so this hints to me that it's probably going to be some sort of sign change that we're doing here, because, right, as we talked about in the last video, y to the 1th can be positive or negative, but y squared is always non-zero. So let's figure out a quadrant to check in here. Let's look at quadrant 2 first. That's this quadrant here, and it's not consistent, right? You've got some positives you got the negative, you even got a 0 right there. It's pretty nasty. So instead, let's try quadrant 4. That's much more consistent, right? Even though this one right there is very close to 0, it is still positive. Okay, so we know that dy dx is greater than 0 when, okay, what points constitute being in quadrant 4? Well, x has to be greater than 0, and y also has to be less than 0. Alright, again, you can see that pretty graphically. So now let's try these options for different for these different choices here and see which one upholds this fact that, you know, dy dx should be greater than 0. So again, I'm just going to pick a point. You can show your work however you want. So maybe one point that is in quadrant 4 is a 1 comma minus 1, right? So now let's try this point here for choice B. So the x coordinate is kind of redundant. We're just looking at the y coordinate. So it's going to be minus 1, a 4 minus a minus 1 all over 4. Okay? And then that's going to be a 5 all over 4, and that's less than 0. Uh-oh, that's not what we want, right? What we want is that dy dx should be bigger than 0. But here we've just shown that for some point in quadrant 4, it is less than 0. So we eliminate answer choice B, and answer choice D becomes the only candidate here. So that's it for this video. Feel free to leave comments or anything in the comment section below. Consider liking and subscribing, and I'll see you guys in the next one.